Okay, so these are the notes for graphing logarithms. The essential question is, how do you find the asymptote of the graph of a logarithm just by looking at the equation? Okay, so our main idea today is logarithmic graphs. And you will want your graphing calculator because we're going to do this all on the calculator. So, parent functions for logarithmic graphs. So what's in blue here is an exponential function. What's in red is a log function. So the log function is just the inverse of an exponential function. And so our domain here, this time, the x values are not all real numbers. And also notice that it is now starting to level off at a vertical line. So the asymptote for log functions are actually going to be a vertical line, and for this parent function, that vertical line is x equals 0 because it crosses the x-axis at 0. So the log functions are different than the exponential functions because these have a vertical asymptote, whereas your exponential functions had a horizontal asymptote. Okay. Now, what we're going to do is we're going to type this in our calculator. So we'll do just like we've normally done. You're going to graph the asymptote on the graph. You're going to graph at least 2 points and then the shape of the graph, and then we'll do domain, range, and asymptote on here. Okay, so log base 3 of x. We're going to type that into our y equals on our graph calculator. So clear anything out. Now remember, we get log base from hitting math, and then I scroll up because it's at the bottom. So log base, and this was log base 3 of x. So 3 goes there, and x goes in here, and so then we can graph it. Okay, so it's that sideways exponential, and if I look at the table, so hit second graph, notice if I scroll up here, an error occurs at x equals 0. So wherever your first error occurs, so this is the first one because I had 1, 0 as a point, and then if I go backwards, 0 gives me an error. So then that 0 there is your vertical asymptote. Okay, so if you look on here, you can pick 2 points to graph. So I'll pick 1, 0, and 3, 1. Easy to graph. So we go back to our graph, and we do 1, 0, and what was the other one? 3, 1. Now our vertical asymptote is going to be x equals 0. So we're going to draw that in, which x equals 0 is actually the y-axis. And so x equals 0. Now how you can tell just by looking at the equation is, remember for exponentials it was whatever that k value was. Well, for these it's whatever is inside here. So this is actually, if I were to put parentheses around this, this is actually x plus 0 when there's nothing else in there with the x. So then your asymptote is going to be inside with the x. Okay, so this one happened to be 0. And if you're not sure, you can always look at your graph. So like I was saying, if I look at my table, wherever that first error occurs after you have a normal number like 1, 0, wherever it says error first, that is your asymptote. So that's another hint as to how to find your asymptote. Okay, and so then from the graph, our shape looks like this. Again, it gets closer and closer to the asymptote, but never crosses or touches. Now this time, it's the domain that's going to match the asymptote. So with exponentials, the asymptote was y equals a number, and so then it was range that matched it. Well, now in log functions, the asymptote is x equals a number, and so then that means that the domain is going to match the x and that number, 0 in this case. And so then we ask ourselves, which x's are we using? And we're using the x's to the right. So the x's to the right are the x's that are greater than the asymptote. And then notice this time the range is going to be all real numbers for log functions because you are using all the y values. Our restriction is on the domain where we're only using the x values greater than the asymptote. Okay, so again, that's a 6-pointer. So 1 point for graphing the asymptote, 1 point for the shape, and then 1 point for graphing 2 points correctly, and then you get 1 point per blank. Okay? All right. So you try this one. So this is log base 1/2 of x. So go ahead and pause this, try it, and then unpause it when you're ready to go. Okay, if I put this in my graphing calculator, so y equals clear, so then it's math, and then you go to log base. And so this is 1/2, so I'll just do 1 divided by 2, and then x, and then graph. Okay, so this time notice our shape is slightly different. It's just going this way instead of down and this way. And if I look at my table, I can get a couple points to graph. So notice the first error happens where I have 1, 0 here, and then at 0, x equals 0 is where I get an error for y. So then that means x equals 0 is your asymptote. So we're going to graph 1, 0, and 2, -1. So 1, 0, and 2, -1. And then our asymptote is x equals 0 again, which is this dashed line here. So it's whatever's with this x inside the log, and since there's nothing in there with the x, then it's x equals 0. And then from our graphing calculator, we saw that the shape looks like this. Okay, so domain matches your asymptote, so it should be x and the 0. And then we're using all the x's that are greater than the asymptote because all the x's to the right. And then range is all real numbers for log functions. Okay, good. All right, now we do also have translations when it comes to log functions. So we don't really, I won't give you anything where you have an a value in front, so you just have to deal with the h and the k on how it shifts. So h, if it's inside with the x, remember it's opposite of what it looks like, and it goes right or left. And this k value goes up or down, and you keep the sign. Okay, so if it's minus h, you actually go to the right h. If it's plus h, then you actually go to the left. Now also notice that your asymptote is going to be x equals whatever this h value is. So if it's minus h, then you have x equals h. If it's x plus h, then you have x equals negative h. So it's opposite of what it looks like in here, just like it is when you're shifting. Okay. All right, so let's look at example 2a. So before I even type this in my calculator, let's do the asymptote. So for the asymptote, you look here. And so this means that we actually shift to the right 3. So that means that this is x equals positive 3. So it's the opposite of what it looks like in here, just like it is when we talk about the shifting piece. Okay? So if you're just looking at the equation, now I'll show you on the graphing calculator how it would have shown you that as well. But you may not, if I just give you an equation and say find the asymptote, you may not want to type it in your calculator. You can, but you may not want to. Okay, so it's opposite of what it looks like in here. So x equals 3. So then when I graph it, I go to 3 and then draw that vertical asymptote at x equals 3. Okay. All right, so let's do the graph. So log base 1/3 of x minus 3. So y equals math log base of 1/3, 1 divided by 3. What's the rest of it? X minus 3. It's inside the parentheses, so make sure that's all inside. Okay, then we graph it. Okay, so our shape, yep, we are shifted over so that it's at x equals 3. And if we look at our table, so we have a 0.40, and then the next one back gives us an error at 3. So then that's telling you x equals 3 is your asymptote. So we'll do 4, 0, and 6, negative 1. 4, 0, and 6, negative 1. And if we look at our shape of our graph again, okay, so it goes this way. It starts here and shoots up. Okay, domain, the x and 3 match. And we know its domain matches this because this is x equals and your domain deals with your x's, and we are using all the x's to the right, so x is greater than 3. And then our range is always all real numbers for log functions. Okay, good. All right, go ahead and graph example 2b, pause it, try it, and then unpause it when you're ready to check. Okay, so if I'm just looking at the equation, remember your asymptote is just focusing on what's with x inside the parentheses, and it's opposite of what it looks like. So plus 1 means we actually went to the left, so x equals negative 1. So then we go to negative 1. So x equals negative 1 is our asymptote. So now let's type this in. So log base 4, x plus 1 minus 2. Log base 4. X plus 1 minus 2 plus 1, and then out of the parentheses you have to put the minus 2 and graph. Okay, so that confirms that our asymptote will be at that negative 1, and we can also see that from the table. So we have 0, 2, and then the next one up is an error, so that means x equals negative 1 is your asymptote. So we'll do 0, negative 2, and 3, negative 1. Ones that I'm going to do. 0, negative 2, and 3, negative 1. And the shape from our calculator look like that. Domain matches the asymptote, so x, negative 1. We're using all the x's to the right, so x is greater than negative 1. And the range for log functions is always all real numbers. We're going to use all the y values. There's no restrictions on y. Good. All right, so last problem. So pause it, try this problem, state the asymptote for the function, and then unpause it when you're ready to check. Okay, so on the exit slip, your asymptote, remember you look inside for log functions, you're looking at what's with x because our equation is x equals a number, and it's always opposite of what it looks like in here because this actually means we shifted 3 to the left, so that'd be negative. So there's your answer. Now, if you just wrote negative 3, you'd get half a point wrong because it needs to be x equals negative 3. That's the equation of the vertical line. Okay, very good. Do a repetition and then work on the problems that go with